Why does ice float on water, even though ice is just frozen water? If ice is made of the same substance as water, you might expect it to sink, just like most solid objects do. But every time we drop an ice cube into a glass, it stays right on the surface. Most solids sink when they are placed in water. But ice does the opposite. It floats. To understand why ice floats, we need to look at one key idea: density. Density describes how much mass is packed into a certain amount of space. When an object is more dense than a liquid, it sinks. When it is less dense than the liquid, it floats. So the question becomes simple: is ice more dense than water, or less dense? When water is in its liquid state, its molecules move freely and stay relatively close together. But when water freezes, something unusual happens. The molecules slow down and arrange themselves into a more organized structure. This structure creates empty spaces between the molecules. Because of these empty spaces, ice takes up more volume without gaining additional mass. As a result, ice becomes less dense than liquid water. And this leads us to a simple rule: less dense objects float on more dense liquids. Since ice is less dense than water, it floats. That is why ice cubes rise to the top of your drink instead of sinking to the bottom. This simple physical rule has powerful effects in nature. In winter, lakes and ponds freeze from the top down. Ice forms on the surface first. This layer of ice acts as insulation, protecting the water below from extreme cold. Because of this, fish and other living organisms can survive underneath the ice. If ice were denser than water and sank instead, many aquatic ecosystems would not survive winter at all. All of this comes from a small change in how water molecules arrange themselves. A tiny difference at the molecular level creates a huge difference in the real world. And that is the science behind why ice floats on water.